Yes, sir.
So we discussed about IP address and MAC address differences also we discussed, right? So in IP address, IPv4 and IPv6, two versions are there that we will see. IP address is a logical address. It's a uniquely identify a device in the network. That point I didn't add it here. Okay. IP address is a unique. It's not unique address. It's uniquely identify a device in network, not another anything in network. So compulsory, you have to tell complete line. Don't say unique address. Uniquely identify a device in the network. Okay, in network we have a multiple type of devices are there. Different devices are there. Okay, so to communicate, so we have to identify a device. See, this is B, this is C, this is D. How we can will able to identifying? Just we are by looking at, right, by names. But in the network, how devices will be identified with a unique. It's to identify the device in with the IP address. Okay, to identify a device, the network. So how to identify a device in the network with IP address. This command not in the same line. Okay, no. Okay, that's the point. So in IP address we have a IPv4 and IPv6 part. Small IPv4. So again IPv6 now it is. Yeah, I will tell about IPv4 only. So at least the main points it will cover. So and then I will tell about IPv6 separately. So small points on the IPv4 is important. Guys, IPv4 is 32-bit length of IP address it is. Whereas IPv6, few points, common points I will tell commonly, guys. 128 bit it is. Total size of IPv4 means number of IPv4 addresses. Number of IPv4 addresses means I have a 10 computers. Each computer I am giving one IP address, means how many IP addresses I need? 10 IP addresses, right? So like that. So in IPv4, total number of IP addresses are around 4.3 billion IP addresses are there. So 2 to the power of 32 is, this is the exact number we are getting. This is the original number of IP addresses. Okay. So this is the total number of IPv4 addresses. It's around 4.3, approximately 4.3 billion IP addresses. Whereas IPv6 is 2 to the power of 128. 3.4 billion IP addresses. So how many IP addresses? Exactly say it is called a decillion. 3.4 into 10 to the power of 38. So 10 to the power of 38 IP addresses you are getting. It means after 34, put 37 zeros, then it is. So what I said is 2 to the power of, right? 2 to the power of 128. You can see 3.4 into 10 to the power of 38. IPv4 and IPv6. Next, IPv4 is 32-bit. Okay, so it represents in a decimal format, and IPv6 represented pure form of hexadecimal format. Hexadecimal format. Now how IPv4 is look like. An example 192.168.10.23. Some example. This is how IPv4 is look like. In IPv6, different ways we can represent IPv6. Like I'm doing like this. Okay, just for our understanding only, I'm giving guys. Not exactly it is same way. Something like that. But 8 blocks are important. 1, 2, 3, 4, 5, 6, 7, 8. So this is the how IPv6 is look like. Okay, and I'm telling you about for IPv4 guys. If you see it divided into 4 parts, it is divided into 4 parts. IPv4 is 32-bit. It is divided into 4 parts. Divided into 4 parts, separated by dot. Divided into 4 part means it is a 32-bit. Divided by 4 means 8-bit. Each part is 8-bit. What is each part? Each part is 8-bit. Okay, that we call it as a octet. That we call it as a octet. That we call it as a octet. So we have a 4 octets separated by in same point. We have 4 octets separated by dot. Again guys, what is this octet? It's a 8-bit number. 8-bit number. So 2 to the power of 8. 2 to the power of 8 means 256. Meaning is 0 to 255. The range of one octet is 255. Now how many octets are there? 4 octets. First octet. The first one we call it as the first octet. Second octet. Third octet. Fourth octet. Some people represent these octets with a W, X, Y, people represent this octets with this like this is W, X, and Y, and Z. Okay. Some people represent certain textbooks. You are telling first octet like a W, first is Y, Z, like that kind of stuff. This is also okay. Depends upon people and they're making more easiness. W portion, X portion, Y portion kind. But it is always try to concentrate. First, give importance to first octet, second octet, third octet, and fourth octet. As I said, each octet size is 0 to 255. Okay, guys. So first octet is ranges from 0 to 255. Second octet ranges to 0 to 255. Third octet is range is 0 to 255. Fourth octet is from 0 to 255. Okay, so 0 to 255, 0 to 255, 0 to 2. So means any octet you take, the number in the octet is not more than 255. Remember that one. Any octet you take, like a 192 or 168 is there, no? So 10 is there, 23 is there. So it is maximum size of this is 255. For example, I'm telling I'm typing an IP address 10.34.56.123. No problem. Okay. For example, I'm typing 10.300.56.234. It is wrong IP address. Wrong IP address. 10.30.56.235. Correct IP address. Maybe remove this one. Correct IP. 0 is also acceptable. But more than 255, it is wrong IP address. Okay. This is correct IP address. 0 is also okay. 0 is also acceptable. Any octet. Okay. So this is correct wrong IP. This is right IP. Okay. So any wrong IP address. Any octet should not be more than 255. Just understand?
Yes, sir.
This IPv4, the range of IPv4 address is 0.0.0 to 255.255.255 means no octet is more than 255 and it is starting like this. Okay. So you start arranging one by one IP address. The starting IP address is 0.0.0.0. So you start writing like my range. So starting is 0.0.0. The second one is 0.0.1. Third one is 0.0.1.1. Sorry, mistake. 0.2. It keep goes and 0.254 reaches, then it is become 255. So highest is 255 because think like this, after 99 what we will get it 100, so it becomes zeros, one will come. After 299 300, after 999 1000. So how numbers are changing? After 9, how it is 0 is happen. Same way, after 255, it becomes 0. 1 will be added to the new one. So like this it will happen. This is the new range. And it will continue. Same way it goes 0 dot 0 dot 1 dot 254. No, sorry, not required 254, 255. It reaches up to this number. Then what happens? 0 dot 0 dot 2 dot 0 automatically. Which become next one. Again 0 dot 0 dot 2 dot 1. It continues like that. So next one is it reaches 0 dot 0 dot 2 dot 1, 2 dot 255, and then 3 dot kind of stuff, right? So then it is goes up to 255 dot 254. So 255 reaches. Then it will go to again 1 dot 0 dot 0. It continues 0 dot 1 dot 0 dot 1. Same way 0 dot 1 dot 255 255. 0 dot 2 dot 0 dot 0. Same goes 2 dot 1 to 2 dot 0 dot 1 2 dot 0 dot 2, like it will goes, it go to 255 255, and finally it reaches 250. Then it become 1 dot 0 dot 0 dot 0 and 1 dot 0 dot 0 dot 1. If you keep writing, guys, it is around a 4.3 billion IP addresses you will write it. Okay, this is also reaches 255 255 255. And it is become 2 dot 0 dot 0 dot 0. Okay, of course. Finally, we reaches 255 255 250. Okay, guys. So this is what I'm trying to say. Point it is. So IP address is starting, IP address is ending. And remember, no octet is not more than 255. Okay, this is the total range of IP addresses. The total, no one is speaking anything, range of IP addresses divided into classes. Okay, there is a big stories about a thing. Okay, so divided into 5 classes. Okay, recognize class of IP address. It is class of the IP address. It is based on first octet of IP address. Okay. First octet of IP address. Okay. Even now you see an IP address, see the first octet. Of course, there is a lot of stories already I told, guys. No, stories are there. I didn't tell you stories, but you can directly go to class A, class B, class C, okay, class D, and class C. In generally, we have to tell in a binary format first, but I am giving direct ranges 0 to 127, 128 to 191, 192 to 223, 224 to 239, 240 to 255. And in some 10 test books, it shows 1 to 126 only. Of course, there is a reason. This is a R&D guys, still research in purpose. Okay, some people using maybe research and development, still evaluating are a reserved, like a reserved for a future use kind of stuff. So class D is a multicast. Okay, it's a multicasting purpose. And also get to know the details. Okay, so we cannot assign certain IP addresses to our NICs. Devices or NICs. Okay. What are those things? 0.0.0, it is a reserved IP address. It is a reserved IP address used in some used by certain protocols like DHCP. Okay, default routing, okay, used at a DHCP default routing kind of stuff. And also this entire series is we are not using this entire 0 series. Okay, we are not using. The next one is 127.0.0.1. Guys, this is very important one. It is also reserved for a local host or loopback ID. Some people local host, loopback ID or a loopback IP address. Okay, so it is reserved. What is the use of this one? Self-testing. Self-testing. Same device. This kind of stuff. And also this entire series is we cannot assign. And also we cannot assign, one more is there, multicast. What is multicast? This use of this multicast. Okay, we can't assign multicast IP addresses to the devices. It is also used by some protocols and certain services. protocols and services. Example WDS, Windows Deployment Service. Port P, DIGRP, RIP version 2, OSPF. These are all okay. Different services. WDS services there. Boot P protocol is the ERP, OSPF. These protocols uses multicast. Okay, we cannot assign to any individual pieces. Class A, Class B, Class C, unicast address. We can unicast address. That's it. That's enough. Which we can. That is, we should not tell that one. Why? Because of already this is also in same category, right? This is also in the class A, class A only, but we cannot assign, right? We can't assign certain IP addresses to our devices 0.0.0, 127 series, and multicast address which is class D. Can't assign. Views in communication class A, class B, class C, that too in class A this range, class B this range, class C this range. So in class A, except this range, we can use it to assign an IP address.
So range of the class is always fixed. Means class B have a 128 to 191.
Yeah,
Is
it
it
is
fixed?
fixed.
Okay, sir.
They divide a total IP addresses, these entire IP addresses into 5 classes. That's it. And it is recognizing based on the range with the first octet W. First
Sir,
octet.
sir, basic difference in multicast and unicast?
Unicast means 1-to-1. You ask me a question, I am telling an answer, right? It means 1-to-1.
Yes, sir.
Okay, so there is a and there is a B. You send ping to A, B, ping B. So it means you are sending ping request to B. Unicast. Okay, so for example, there is a devices A, B, C, D. All are working on a certain service. All are working on a certain service. And there is a packet is given to something or so means it's a group name. Packet sent to this, it means packet is same for all the devices. Not like that simple. Like if I send a individual message, okay, in WhatsApp we can send a message individually, right? So then it's a unique cast. And people who are in the WhatsApp group, like we are all in the WhatsApp group, if I put a message here, the message go to people who are in the group. Okay, people who are in the group. For example, if I send a message in broadcast, so people who are in the broadcast group, they'll get a individual messages. Okay, see this is one-to-one communication. This is group-wise communication. Exactly not group, not this group. I send a message to some a kind of group it is. Okay, one address. I am sending to a particular multicast address. So then the messages go to every device which is in that particular multicast address. It's
Okay, sir.
recognized by service or protocol. this is your IP addresses and ranges, guys. So I will tell about a network and subnet portion, but before going to that one, you should know how to recognize IP addresses. So recognize the IP addresses based on their first octet, right? So I will give you one example: 134.88.201.191. What is the first octet here? This is the first octet. W portion. W portion. Okay, first octet. So 134. Check the list. Where is 134? Right, class B. This belongs to class B. Next one onwards, you should tell. 56.178.191.2. Which class it is?
Class A.
Class A. Very good. A. Very good. So it is. Check
Class
the
A.
first octet. Yes. Check the first octet. What is the range? 56 in the class A. Good. Good, guys.
Class B.
Very good. Class B. Very good. Okay. So how to know? Check the first octet and go to the list. Class B 156. Which class it is?
Class C.
Class C.
What is the first octet? 195.
5.
Where is 195?
In class C.
Class C. Very good. Which class it is? What to do first? Click the first octet. Go to table. 110.
D.
210. 210. 210.
Class C.
Sir, C.
Class C. Similarly to 24. Which class?
Class D.
Class D.
Class
Yes.
Class D.
Yes, sir.
Like this, we can recognize. If you take more than 240, it is 242, 255, it is class C. So I hope you got the point how to recognize. This entire IP addresses is divided into network and host version. IP addresses, oh, it is 125, okay. IP addresses divided into network and portion. Not position, portion. Okay. So why it is happened to this? Network portion and host portions. What is this network and host portions, guys? Just for an example, I am telling this, try to understand. So I'm giving your roll numbers. Giving some roll numbers here. Understand what is your batch? A batch 18. Roll number 1. This is roll number 1. Batch 18, roll number 2. Batch 18, roll number 3. Batch 18, roll number 5. Batch 18, row number 9. 09. Batch 18, row number 12. Okay, these are the attendance I got it, for example. Okay, so roll number 1, roll number 2, roll number 3, roll number wise I call the attendance, I got it. But I have written 18. Why 18? The 18 represent 18 represent
Batch.
yes. And what is this 01?
Number. It's a roll.
Roll number.
Roll number. It represents a person, right? It represents person. Roll number. It represents a person name, like that. A person or a person name. Same goes for this one. Suddenly, another person is joined. In between, a new person is joined. So, for example, batch 17. I am not handling that one, but this person is joined. So, what batch I am in my place? I thought it is 18th batch, but when I got it, so this is 17.11 is there. 17.11 is there. So this guy belongs to batch 17, not belongs to my batch. Right? That's how we are dividing. The similar concept is network and host portions. The similar concept is again network and host portion concept. The network represent what network you are belongs to. The similar network we can able to communicate. Network. Host means computers or devices. We can better I will tell devices in devices are in same network means devices are in the same network can communicate each other means their network portion is same. The network portion is same. Their network portion is same. So network portion must be same. And host portion is different. So point is network portion same and host portion not entire host portion, at least some part of host portion is different. Some there is some part of host portion is different. Network portion compulsory must same. So must be same. Okay, their network portion is same. So network portion must be same and host portion is different. Host portion is different. So this is the point I'm trying to say, guys. Again, how to know which is the network portion, which is the host portion. giving a default information. This information may varies from one to another one. So what is the class A range? 0 to 127. Of course, we are using 1 to 126 range only. 0 we are not using. 127 we are not using. 128 to 191. 192 to 223. It's a unicast addresses. That's why I am typing these details on. So in class A, the first portion is network portion by default, and the remaining portions are host portions. So for our class A IP addresses, the first portion compulsory same, remaining can be different. Class B, first two portions are network portions, and remaining become host portions. First three portions are network portions, and this portion is host portions. To recognize, we can recognize which is the network portion, which is the host portions. Okay. So how to recognize by typing an IP address? We have taken some IP addresses here. Same only I'm taking. I'm not taking differently except the class D, because class D we are not using. So I'm removing class D. The first recognize which class of IP address it is. Which class it is? Class B. Class B network portions. First two are a network portions. So these two are a network portions. So what is the network portion of this one? First portion. This is which network? What is the network portion? This is the network portion. What is the network portion here? The first three are a same network portion. This is the network portion. So class C. This is a network portion. Okay. So we can write like this: 134.89 is a network portion. Okay. So the portion, and 201.191 this is host portions. Okay, here it is. Your 56 is your network portion. 178.191 okay. So here it is. 195, 123, 127. This is network portion. And what is the host portion? One is the host portion. Okay, one is the host portion. Here also same. 210.22 is our network portion. And what is the host portion here? 10 is the host portion. So why we should know the network and host portion? So simple. I will take one example from here. First example again. Example. I have examples already in the PPT. Some other examples also there, but I am taking similar examples. Okay, small changes. I'm removing this class B kind of stuff, which we are already knows. So guys, what is the network portion? 134.89. This is the network portion. What is the host portion? This is the host portion. Here, host portion is different. Host portion is different. Both the side network portion is same. Okay. For example, you have a computer called a PC1. PC1, PC2, two computers are there. So as a given a statement, network portion must be same, host portion can be different. Okay, host portion can be different. So then they will communicate each other. Okay, so I have a 3 computers totally now. So a third computer, no one is, yeah, no problem guys, it's already time up for you also. People are getting hungry. This is only one example. I will leave you. Okay, so you have any doubt, then also you can tell me. Okay. So what is the network portion is here? The network portion is different. Host portion is can be anything. So host portion is can be anything. Same or different, we don't mind about it. Okay, one similar or maybe different. So this is the host portion. This is the network portion. This is host portion. Similarly, this is 134.88, and this is so guys, PC1, PC2, PC3, PC4 is there. So PC1 and PC2 can communicate each other. Why? Their network portion is same and host portion is different. Not communicate to PC3 and PC4 too. Cannot communicate it to PC4. Why? Because of their network portion is different. Their network portion is different.
Sir,
Yeah, tell me.
sir, we have to remember all these things.
You should understand. Of course, you have to remember us.
Achha.
What are the things to remember? Yeah, very good question. So that's I will tell and wait. About IPv4 guys, how to check IP address, how to check MAC address, okay, and about IPv4 and IPv6 address, okay. So very important point is the octet ranges, class A, class B, class C, and network and host portions, okay. This part plus a default subnet mask, default subnet mask. Where the network portion is there, there a subnet mask is also there. This table is also important. So this is default subnet mask. Okay. So we can understand what is the network portion and host portion. How system will understand. System divide IP address into network portion and host portion using subnet mask. What is the use of this subnet mask? Subnet mask divide IP address into network portion and host portion. Subnet mask used to get network ID okay, from your IP address. Okay. Devices in network, devices in the network need devices in the network must be have same network ID. So like earlier I said, they must be in the same network, means their network portion must be same. Same point only. It is the same point, but I tell in a network ID manner. So devices in the network must have a same network ID. How you know the system same network ID? By subnet mask. Okay, this is the default subnet mask. Default subnet mask is for a class A Wi-Fi.0.0.0. The class A range is 0 to 127. Okay, this is your class A range. Class B range 19. Why I am typing again? Because guys, that is the way you can easily remember things. Repeatedly telling, and if you are at least read once, you will remember. Okay, this is a default subnet mask of a class A and class B, class C. Class D, class C do not have subnet mask because we are not in the unicast communication. This is unicast communication. Class D is a multicast, class C is we don't use it anyway. Okay, so we are in the multicast addressing compulsory. There is a subnet mask to divide an IP address from network portion. Same network ID or same network portion devices can communicate each other. Okay, can communicate each other. Okay, so that's the point. I given one example also in PPT. I shared the PPT, right? If I don't, I think already I shared a PPT. In this one, in an IP address portion, you can get a. Anyway, I will share it once again. So what is the one? In this one, again, IP addresses. There some more examples I have given. You can try that one. So guys, this is about IP addresses, mainly IPv4. So I told about mainly IPv4 here, not IPv6. IPv4 32-bit to 4.3 billion IP addresses represented in decimal format. Okay, it is divided into 4 parts and separated by dot. Okay, so here it is each part is an octet. 4 octets are there. First octet, second octet, third octet, fourth octet. It is separated by dot. The total IP address ranges is 0.0.0 to 255.255.255.255. These total ranges is divided into 5 parts. In a class C part is reserved, we are not using. Class D is a multicast addressing. Class A, class B, class C, we are unicast addresses. In a class C, range is 0 to 127, but it will show us as a 1 to 126. Why? Because of 0 series is reserved IP addresses. 0.0.0.0 is used by certain protocols and certain services. 127.0.0.1, it is a reserved IP address for a loopback or a local host address. It is used for self-testing and same device access purpose. So maybe on Monday I will try to explain it clearly. Okay, multicast addressing also we cannot assign to any devices. Class B is a 128 to 191. Class C is 192 to 223. Class D is 224 to 239. Class E is 240 to
So
255. Yeah, tell me.
loopback ID means and a subnet mask.
Okay. Yeah. So local host or loopback. Loopback is usually for self-testing. Means if in case I am unable to communicate it to any other devices, outside devices. So I thought it is my PC TCP/IP application problem, TCP/IP service related problem. So I want to check this TCP/IP service is working or not. So what I will do, I will try to ping to 127.0.0.1. It is a loopback type, means it's a self-testing. I am testing my system, my services. Is it my protocols are working, ping command is working, is the TCP/IP type of communication is working or not? I can able to test it. That is loopback testing. Next one is local host. What is a
No,
local
sir.
host?
A
Yeah.
local host I can understand a subnet mask.
Yeah, subnet mask is actually you have an IP address. Okay, you have a certain IP address. What your subnet mask will do, uh, we know what is the network portion and host portion by default. Okay, but we want
Yes,
to
sir.
change that one, or maybe the system should understand what is the network portion and host portion. How system will understand, they use a subnet mask. And I didn't add this point here. Subnet mask uses end gate operation. This is a logical gate. Okay,
Yes, sir.
there's different logical gates are there. Use end gate operation. Okay, to find network ID or a network portion. Network ID and network portion. Okay, that is the first thing. Okay, so what is this end gate operation and all? That is, we can see how system will understand, how system will calculate. So depends upon the subnet mask. It is a default subnet mask. You can change the subnet mask. So change of subnet mask changes network and host portions. A big story is there because already time up. Okay, so these are the important point, guys. Default subnet mask, IP address, classes, and their ranges. IP address classes and what is an IP addresses? What is IPv4, IPv6? IP address classes and their ranges, classes and their ranges. This is 127.0.0.1. This is another very important one. Okay, loopback or local host address, and how to recognize an IP address, which class of it, and how to recognize an IP address, the network portion and host portions. Up to here I told. Okay, and what is the subnet mask? What is the range of subnet mask? What is the use of subnet mask? How subnet mask works, that is also we can able to explain. Again, it will take another 5-10 minutes. Like one by one, it will add it. Okay. Up to now, it is enough. Okay. Up to now, it is enough. Our next Monday class, I will tell few points about IPv6 and NAT/PAT OSI layer. I will finish on Monday this part. Okay, guys.
Okay, sir.
Okay, sir.
Okay, sir.
If I
Thank you,
will
sir.
possible, I will
Thank
make
you, sir.
test for you. But before that one, complete this test by evening 6 o'clock. That
Okay,
much
sir.
time I given, but compulsory right after
Yes, sir.
lunch at least complete it. Okay, evening I will upload. Then tomorrow you can write it.
Okay.
Okay, about IP address related, both 1, 2, 3. First class, second class, third class, all classes, plus mainly IPv4 address related. So you will avoid it. Thank you, guys. Thank you. Bye bye.
Thank you, sir.
Thank you, sir.